Welcome to Maths and Science by IITian channel. In this lecture, I will be taking up a challenging question for JEE Mains and also for JEE Advanced. What is the matrix to the power of a matrix? A is a matrix to the power of A. How you can represent it? Till now we have seen A into A is equal to A square, A into A is equal to A cube, and polynomial of a matrix. But when matrix is raised to the power of another matrix or same matrix, in this we will discuss about the same matrix. When a matrix is raised to the power of same matrix, what will be its value? You might have already seen in my earlier lectures e to the power of A. E value you know, logarithmic exponent, that is E is equal to 2.178. E to the power of A is equal to how much? This we have already seen in my previous lecture. Please refer to that lecture for understanding this lecture. And e to the power of A is already understood by us. Now, what is A to the power of A? A is a matrix. If A is a matrix, what should be A to the power of A? It's out of my intuition. I created one matrix and I wanted to know what is the value of A to the power of A. That's I wanted to explain you. Now, if you understand this, matrix to the power of matrix, E to the power of a matrix, then this type of questions, if they appear in your JEE Advanced or in your JEE Mains examination, you will not be surprised. You will be able to understand them and you will be able to answer them. This type of surprise questions may occur in your matrices. We can't say what type of questions do come in JEE Advanced. But however, we should be ready and equipped with all the types of problems which may occur, because topic is matrices. A question can be asked A to the power of a matrix to the power of a matrix. Now, let us delve into the problem. There are certain things which you should understand. A matrix A is there. Matrix is equal to A. Then, can we write, just try to understand this. Let this matrix be, let me take one diagonal matrix for our understanding, 3 0 0 5. Let us try to solve A to the power of A is equal to how much? Now, a matrix A to the power of A, can we write it as E to the power of A ln A? Are you able to understand? Here, we are thinking whether this particular equation is valid or not. On many occasions, I have told you previously also, x to the power of x is equal to e to the power of x ln x. This is a very important equation. If you take natural logarithm on both sides, it will be x into ln x is equal to x ln x into ln e to the base e. This is equal to 1, which implies x to the power of x is equal to e to the power of x ln x. In the similar way, can we write a to the power of a is equal to e to the power of a ln a? We may not be able to write under all circumstances, but it could be written. Let us not dwell into the depth of the subject. Because too much in depth if you go, you will lose the main concept. For simplicity, let us take this is valid. This is valid under certain conditions. Those conditions I will let you know. One is the matrix A is diagonalized. That means it can be diagonalized. First and foremost condition is that we should be able to diagonalize the matrix. What is diagonalization? That it's a little bit an advanced topic than what is taught in class 12 and class 11 matrices. If you prefer a lecture on that about diagonalization, I will be giving the lecture if you ask for that in the comments. For the time being, we will take that A can be, a matrix A can be represented as PDP. P into D into P inverse. This where D is equal to diagonal matrix containing eigenvalues of A. Okay? If A is equal to A can be represented in the form PDP inverse, where D is the diagonal matrix containing eigenvalues of A. This is a process of diagonalization, and P is a matrix whose columns are eigenvectors of A. That means, to understand the concept A to the power of A, we are required to know eigenvalues and eigenvectors of A, and D is equal to diagonal matrix containing eigenvalues of A, and P is a matrix whose columns are eigenvectors of A. And if A can be represented in the form PDP inverse, then that matrix A can be solved for A to the power of A in the form E to the power of A ln A. This can be used when this can be satisfied. I think you might have understood this, because all these things I have explained in E to the power of A and my lecture on eigenvalues. Please refer to that also, how to find the eigenvalues from characteristic equation, then how to write the eigenvectors and from them. And to cut short this problem, the given matrix A is equal to 3 0 0 5, P is found out as 1 0 0 1, so that P inverse is equal to 1 0 0 1. Once you go through the process of eigenvectors and eigenvalues, we have found that P is equal to 1 0 0 1 and P inverse is equal to 1 0 0 1, because I inverse is equal to I. Please remember this also. Here it is nothing but I, so that P inverse is equal to P is equal to I. That's what we have got for this matrix. Please prove this. Find out the eigenvalues and prove that eigenvectors, that P is equal to I. This is the P is nothing but a matrix whose columns are eigenvectors. The eigenvectors, this is the eigenvector 1, this is the eigenvector 2. This is the eigenvectors matrix. If here it is proved that, if A is equal to 3 0 0 5, if A is equal to 3 0 0 5, it implies P is equal to I is equal to 1 0 0 1. This you take it as a homework and prove. Eigenvalues, eigenvectors I have already explained you in previous lectures. It's an advanced topic. Please try to understand each and every sentence of mine. Please try to implement them. Do your homework and see that eigenvector is equal to P is equal to I, that is 1 0 0 1. Eigenvectors are 1 0 and 0 1 are the eigenvectors. Eigenvectors for this matrix or eigenvectors is equal to one is 1 0 and another is 0 1. These are the eigenvectors. The column matrix of these, when you combine these two, then P is equal to 1 0 and 0 1. P inverse is also I. Okay. Then A is equal to, what is the diagonal for diagonalization? A is equal to P into D into P inverse, that is I into D into I inverse, that is equal to D. That means A is equal to D. That means the eigenvalue, the diagonalized eigenvalues matrix is equal to A itself. In that case, we can use, what is that property? What is the property? A to the power of A is equal to E to the power of A ln A. That is going to be, which implies A to the power of A is equal to E to the power of A ln A. Now here, the value of A ln A is to be, it is the challenge. Here it is the challenge, is equal to how much? Then we can say that A to the power of A is equal to so and so. Then what is the value of A ln A? This is the challenge. A ln A is equal to, under above conditions for which A is defined, where P inverse and D are found out, and it is found that A is diagonalizable. Please try to understand. That means A is equal to diagonalizable. Diagonalization. Diagonalization is valid under above circumstances. Then A ln A is equal to A to the power of A is equal to E to the power of A ln A, and we have to find out A ln A. A ln A can be A into, what is A? 3005 into what is ln A? Because it is diagonalizable, we can directly add ln here. Ln 3 0. Only for diagonal elements we will put logarithm, not for zeros. That you should be. For coming to this conclusion, only to put logarithm, natural logarithm for principal diagonal elements, we have to check whether diagonalization is valid or not. If diagonalization is valid, then in that case, for the diagonalization matrix, we apply logarithms, because we cannot apply logarithm, ln 0 is undefined. To avoid the situation of ln 0 being undefined, ln A can be written as, when diagonalization is valid, you please understand this, when diagonalization is valid, for the given matrix from A is equal to P D P inverse, for A is equal to P D P inverse and A is equal to D, then when diagonalization is valid for this particular example A is equal to D, then ln A is equal to ln of diagonal elements to be considered and not ln of zeros. That should be avoided. Then it becomes ln A is equal to, this is an important conclusion. From this, ln A is equal to ln of, what is D? D is nothing but eigenvalues matrix. This eigenvalues matrix is nothing but A. We have found out. That is ln of lambda 1, 0, 0, ln of lambda 2, which is nothing but ln of, what is lambda 1, lambda 2? That is 3 and 5. ln of 3, 0, 0, ln of 5. Because the diagonal matrix of eigenvalues is same as A from the previous discussion, because D is equal to A. Are you able to follow? Please try to follow. If you want, you see the lecture again and again. This is a very important step. ln A from the conditions, because the conditions are fulfilled, ln A is simplified to ln 3, 0, 0, ln 5, because D is equal to A and A is equal to 3, 0, 0, 5. We will not take logarithms of 0, because D is equal to A and A is eligible for diagonalization, and we will take only the eigenvalues, logarithm of eigenvalues and the logarithm of ln lambda 1 and logarithm of lambda 2. Logarithm of lambda 1 is ln 3, logarithm of lambda 2 is ln 5. Now ln A is equal to ln 3, 0, 0, ln 5. Now you tell me. Now problem is solved. Now what is A ln A? A ln A is equal to 3005 into ln 3, 0, 0, ln 5. This you can do like ordinary multiplication, that is 3 ln 3 plus 0, 3 ln 3 plus 0, next 0 plus 0, next is 0 plus 0, next is 0 plus 5 ln 5. This is ordinary matrix multiplication. Then what is A ln A? Is equal to 3 ln 3, 0, 0, 5 ln 5. There may be a shortcut writing directly A ln A value. Please don't do that. Please try to understand and analyze whether this given matrix is diagonalizable or not. Then only you apply this principle. This is A element lambda 1, or we can say A11 into ln lambda 1, 0. 0 A2 to ln lambda 2. To derive this, to conclude this, directly don't apply the formula, for God's sake. Try to understand the concept behind it. For that only I have taken time to solve this. Otherwise, I can directly write the formula and say that this is what you use that formula. Mathematics, certain formulas are applicable under certain conditions only. And this will be A ln A we have got. Now, what is A to the power of A? That is E to the power of A ln A. That is E to the power of 3 ln 3. That means A to the power of E to the power of this matrix. What is this matrix value? 3 ln 3, 0, 0, 5 ln 5. I have already discussed about E to the power of A. E to the power of A is equal to I have already discussed about E to the power of A or E to the power of any matrix for that matter P in my previous classes. Using that theorem, let us say this is the matrix P. Using that concepts, please see that particular video, where it is written as under certain conditions, it is this is homework, please see that. And this A to the power of A can be written as 3 ln to the power of 3. When you make it E to the power of 3 ln to the power of 3, what is the value? That is 3 to the power of 3. A to the power of A can be written as, because E to the power of 3 ln to the 3 ln 3, that is E to the power of 3 ln 3, E to the power of 3 ln 3, 0, 0, E to the power of 5 ln 5. From this, what is E to the power of 3 ln 3? That is nothing but I have already told you, E to the power of A ln A is nothing but A to the power of A. In the similar manner, E to the power of 3 ln 3 is nothing but 3 cube 0, 0, 5 to the power of 5. Why? E to the power of 3 ln 3, let us say that is equal to x. Then, taking logarithm on both sides, 3 ln 3 into 1 is equal to ln x. If x is equal to 3 to the power of 3, e to the power of 3 ln 3 is equal to 3 to the power of 3, let us say. We are assuming x value. Then 3 into ln 3 into ln e to the power of base e is equal to 3 ln 3. That means 3 left hand side is equal to right hand side. That implies e to the power of 3 ln 3 is equal to 3 cube. Are you able to follow? This I have discussed many times. This one concept, that means e to the power of a ln a is equal to a to the power of a. This is one concept which I have explained in my logarithmics equations on many lectures. Please refer to them. This is one concept, and when diagonalization has taken place, the given matrix is diagonalizable, then a to the power of a is equal to, this is another concept which we have to see, e to the power of a ln a. If diagonalizable matrix is there, then it can be written as a to the power of a is equal to e to the power of a ln a. This can be written as a11 to the power of a11 0 0 a22 to the power of a22. Just see how easily, by shortcut you can easily get the answer, but I wanted to explain the concept behind it so that you will understand. Now, if any question is given, find a to the power of a if a is equal to 3005, then solution is a straightforward solution is a to the power of a is equal to a11 to the power of a11 0 0 a22 to the power of a22, provided all the above conditions, diagonalization condition is fulfilled, and a matrix is a non-singular matrix. Diagonalization conditions are all fulfilled, and eigenvalues and eigenvectors are found, and PDP P inverse is equal to A, provided A is equal to PDP P inverse and P is equal to I and D is equal to A. These conditions are fulfilled, then we can directly write it this way, and for the given matrix it is 3 cube 0 0 5 to the power of 5, that is equal to 27003125. This is the answer. Now, you might have understood that a matrix can also be raised to the power of a matrix. A matrix can also be raised to the power of a matrix. And if instead of A, if it is A to the power of B, if A and B are two different matrices, what is the procedure to be followed? Please check for this. It's a challenging question. Yes, definitely. Please check for this. It's a challenging question, challenging concept, and a new concept, definitely. And it's a very good concept. This type of questions, if they occur in JEE Advanced or JEE Mains, please don't be afraid. Please solve them and remember this. If they give also, they may give a very simple problem to you, 2 by 2 problem. If they give bigger problem also, you can use your intuition and solve it. And this is what is this here. 3 and 5 are eigenvalues. Simply you see that D is equal to A and P is equal to I. In this particular problem it is like this. For that only we have put these values. eigenvalues, eigenvectors you find out. And in this particular problem, provided this can be used, provided this happens, and in this particular problem this A is equal to PD P inverse and P is equal to I and D is equal to A has happened, hence we have directly used this formula and got the answer. But if not so, then we have to follow the full process of diagonalization, ending finding P and also finding D separately, and then we have to go for this answer A ln A, and e to the power of A ln A will give the answer to you, and that is matrix to the power of a matrix. Then you can have this type of problems, you can create your own problems, you can develop your own problems, solve them. For example, I will give another question to you. What you call, I can rather, if I put A is equal to, try to solve this problem. A is equal to, try to solve. A is equal to 0 1 minus 1 0 and find out what is A to the power of A. On the similar lines, you try to solve it and find out what is A to the power of A. These are all challenging problems, good problems, and they try to intuit you to the expand the intuition for you and try to solve them. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture, and if there is a value addition to you because of this lecture, then please try to share my video and my channel and try to subscribe to my channel Maths and Science by IITian. Here what I am doing, I am giving a vast scope to mathematics, starting from number theory and prelims, factor definitions, to advanced linear algebra, advanced differential equation, advanced integrals, improper integrals, advanced definite integrals, solving definite integrals using Leibniz theorem and residue theorem on in various videos, so that you can see them and get the concepts and try to solve them and expand your knowledge. And I will be definitely doing not only the tougher problems. It is not about the whether problem is tough or easy. How much you have understood the concept is more important, so that you will be able to apply them in the examination and try to understand. Thank you. Thank you for listening to me. Thank you for viewing my lecture. Please subscribe to my channel Maths and Science by IITian for regular updates.